Hi everyone, Gaurav this side. So we'll start our ENCOR class from today. I got some message in chat also. Ahmed, are you there on audio? I mean, are you able to hear me? Because I see that your mic is not there.
Gaurav, good morning.
Hey, hi Hemchandra. Good
Yeah,
morning.
this is yeah, fine. This is first class, no? Encore.
This is first class. Yes, this is first class.
Okay, got it. Thank you.
Okay. All right, then let's begin our first class. I'll start sharing my screen and we'll continue from there. Okay. Hope I am audible to everyone. Okay,
One
so
more, Gaurav, one more thing. And time
hmm,
will be same, no, for every weekend.
time will be same, but since we have a few festival also, I mean
Ah,
next week, so there
that's
may
good.
be slight changes, but yeah, regularly, I mean this will be same, 10
Okay,
to 12 as like we have in our NRC classes,
Hello.
Saturday, Sunday.
that's good. Good. Okay, thank you.
Yeah, anybody have anything to say? Okay, all right. So let's begin our class. Okay, ENCOR. This class is about ENCOR. So in our previous one of the demo class in which we went through what is there in the curriculum and what is the methodology that we follow. Okay, I hope you were part of that.
Yeah,
So
actually, Gaurav, I will not be part of that on the
no,
classes.
no problem, Hemchandra. You already were part of our NRC classes, so
Yes.
pretty much you know. I mean, how we go through the course and
Okay, okay,
okay, so that is same. Otherwise,
okay.
I just went through what is there in the syllabus. So
Mm-hmm.
that's not a big deal. I mean, we'll
Okay.
cover that.
Thank you. Thank
Okay. So today is the first class of our ENCORE. So I'll start with some of the basics of our LAN switching and routing also. Okay. I hope all of you guys are at least CCNA trained. I mean, you are well versed with what we say that IP subnetting. Okay, what is IP? What is a switch? What is a router? This all things are
Hello.
already there. Yes, please. CB, you have a question. CBR, do you have any question? Okay. Uh, Switching and routing. Okay. So first I'll start with let's consider that what is switching or how a switch works, right? For example, let us consider that there is a switch. Okay, and we have some host connected over here. This host may be anything. This may be a laptop, PC, workstation, server, okay, or anything, right? So can anyone tell me how does a switch works basically? Let's say there are two hosts connected on the same switch. Okay, what is the purpose of this switch? What it exactly does? Anybody?
Work on R request, R reply, request and reply. Also L2 FEF, the switch is L2 switch.
Yeah, okay, yes, we assume that this is my L2 switch.
This is work on L MAC based work. Yes.
Okay, so L2 means in Ethernet that will work
Mm.
using our MAC addresses, correct? Right? So MAC to manage these MAC addresses, there should be some table in which it will learn those MAC addresses and maintain that table. Okay, if we consider that it's a kind of a table, within that table, I would have a column, let's say, which is having MAC addresses, right? And on which port which MAC address lies, right? Apart from this, it will also maintain in which VLAN that particular MAC or port belongs to, right? For example, if I assume that this is port 1 and this is port 2, right? Port 1 and let us assume this is port 2, okay? And H1 does have a MAC address, let's say this is the MAC address if we assume, okay? and this is the MAC address for H2. Okay. Now what happens? Can anyone tell me? I mean, let's say H1 wants to communicate with H2. Okay, and we assume that these both the ports are in same VLAN. This is also in VLAN 1. This is also in VLAN 1. What will happen? How this communication will happen? Anyone, please participate and share whatever you know. I mean, maybe right or wrong, doesn't matter, but let's participate. How does this H1 and H2 tries to communicate with each other? Okay, so let's say H1 wants to send any packet towards H2. Okay, H1 will send some, this is my Ethernet, so it will send that in an Ethernet frame, right? So within that Ethernet frame, you must be knowing that Ethernet frame does have an Ethernet header also. That is also known as your layer 2 header, right? This is L2 header or Ethernet header. Within that L2 header, I do have a source MAC and a field named as destination MAC. So these two things I do require in order to create this actual frame. So this H1 does have that MAC address of H2. Initially, do I have that information? Okay, may or may not be. If I do not have, okay, if I do not have that MAC address of H2, okay, I only know that this is the IP address of H2. Let's say this is 1.1.1.1 and this is 10.1.1.1.2. H1 only knows that I wants to ping 10.1.1.2. Okay, he knows the IP address. So before L2 header, I will have a L3 header, okay, which is your IP header. Within that, I would have my source IP, destination IP, that information I do have, right? This I already have, so I can create that IP packet. So after that, I'll have a Ethernet header. Within that Ethernet header, I need to populate this source MAC and destination MAC. Source MAC I already know, but I may not have this information of destination MAC. Then what I will do is I'll be sending a ARP request from here. Okay, I'll be sending a ARP request from here. That is address resolution protocol. Why do I need that? Is because I know the IP of this one H2, but I want to know what is the MAC address of this IP. Okay, why do I want to know? Is because I want to create this Ethernet frame. I want to draft this Ethernet frame so that I can send it on the wire. Okay, it will send that ARP request. ARP is sent as a broadcast. So once this ARP request reaches till our H2, H2 will respond it back towards H1. Yes, this is the MAC address, which is against this IP address. So now H1 does know the destination source MAC. It already knows. It also knows the destination MAC. Right? I have this information also. Source MAC. So now I can create a frame and send it towards the wire, towards switch 1. But before that, I mean, when we send the ARP request from H1 and ARP response sent from H2, what does this switch does? Switch is learning or populating that information in its MAC table also, because when H1 sends you an ARP request, so within that ARP request, I'm also sending my MAC address. So switch 1 is at the same time, I'm populating that at port 1, there is a MAC address, this one, it is connected and that is there on connected on port 1 and this lies in VLAN 1. So this information switch is also populating in its MAC table. Okay, same time when you get a ARP response from H2. Okay, the MAC address of H2 is also being learnt at port number 2 of this L2 switch. So here also it will populate its MAC table. Right? So that's how your switch is populating its MAC table. Now, anytime, okay, anytime any frame comes at this switch, okay, maybe it is coming from any port. Let's say this is port number 3 or port number 4, but you know this switch can read this frame because it's a layer 2 device. It can read that frame and it will only check the destination MAC address. Where is that MAC address? Do I know that MAC address? Okay, yes, I know this MAC address in your destination frame. It is connected to port number 2. So it will automatically receive that frame at port number 1 and switches towards port number 2. No other port will get any that information. It is automatically being switched towards port number 2. So that's the purpose of your switch. Okay, so it is getting a frame, maintaining a MAC table, and based upon that MAC table, it is switching your Ethernet frames towards your destination port.
Hello,
Any
Gaurav.
questions? Yes,
Yes,
Himachal.
Gaurav. Yeah, Mac as port one is maintain cable port two or port one maintain cable on Mac table. Whenever it goes frame port two, that way is opposite vice versa or same table. Suppose.
No, say again, please.
Yeah, suppose port one is of H1 is send request for H2. Okay.
Hmm.
Then port one has switch one have MAC table. Okay. That
Switch one
switch
have MAC table. Yeah.
that switch has table the all MAC address port two all MAC address table or particular one port MAC address table MAC table.
No, see, this table is having three columns: MAC
Okay.
address, port
Mm,
number, and the
mm,
VLAN number.
okay.
So that's how it is capturing and populating that information.
That all. Okay. That is related. Got it.
Yeah, that's how
They
it
will
is being
check. They will
populated.
check. They will check that MAC does exist or not port two in this MAC table.
Yeah,
Got it.
whomsoever is not asking the question, please, I request you to go and mute.
Means
Okay.
port one port whenever request goes to S2, then the switch check that as port two MAC address exists in this table or not.
Correct. If it
Yeah.
exists, it will
Hmm.
immediately switch that packet towards port
Forward.
number 2.
Okay,
Yeah, it will
forward.
forward that packet toward port number 2. As
Hmm.
like in our routers, we are
Hmm.
maintaining a routing table,
Yes, yes, they'll check
right?
routes.
Yeah. Here we are checking the MAC address because it's a layer 2 switch. It
Hmm.
works on the layer 2 frame or layer 2 header. So within
Okay.
that layer 2 header, I have this destination MAC address, which is being used to forward your
Okay.
frames.
They will any size of the MAC address table for that it MAC that will only that MAC address will store on any
No,
size.
no. It's not about any limited according to a
Oh,
size, but
okay.
based upon the memory of your switch,
Okay.
it populates.
Popular.
Okay, and this MAC address, you must be knowing that this is of a 48 bytes MAC address.
Mm-hmm.
Okay, and VLAN, yes, it is having port number. It is having, and this MAC entry does have a default timer of 5 minutes.
Okay.
Okay, if there won't be any communication for 5 minutes, this will get automatically flushed from this
Okay.
MAC table.
A plus. Good.
Yeah,
Yeah.
I mean, next time it will have to again relearn that MAC address by
They,
this communication.
they will learn what dynamically.
Dynamically, it is learning dynamically. It can
Okay.
be defined statically also. I mean, statically also on a particular port, you can bind one particular MAC address. That is
Uh-huh.
also possible. But
Yeah.
usually, I mean, in 99% of the scenario, the switch is working dynamically,
Yeah.
learning the MAC address, storing in its MAC table.
After 5 days, they will be right out of no request. Okay, got
This is the default timer.
it. Default time. Got
It can be changed also, but this is the default.
it. Okay. Thank you.
Okay. Anybody have any questions so far? All right. I'll remove this one and let's think about how actual the frame being sent. Okay, let's consider that same scenario. Switch one. Okay, on port one, you have a machine connected H1. This is having a MAC address of AAA. Okay, similarly, here it is H2 MAC address BBB. Right? The frame H1 will create. Let us assume that they both have learned the MAC address of each other, and source IP is this one, and this is my destination IP. Your switch also have its MAC table already populated. Um, port one, port two. Port one does have this MAC address. Port 2 does have this MAC address, and both are in VLAN 1. Okay, let us assume like this. From H1, when it starts sending a frame, what will be the structure of that frame? If we think that this is my payload. Okay, payload may be, I mean, it can be an ICMP packet, it can be a UDP packet or whatever. Okay, apart from this, let us assume that this is my source IP will be source IP. This is your destination IP. And if I choose another color, and let us assume this blue one is my Ethernet header. Okay, it does have some source MAC and a destination MAC, right? So source MAC will be A triple A, destination MAC will be triple B. Similarly, your source IP will be 10.1.1.1, destination IP will be 10.1.1.2. Correct? As soon as this frame reaches at port 1, what it will do is it is going to check this destination MAC within that frame. Correct? This destination MAC, it exists on port 2. So it will automatically switch towards port 2, and this will be sent over here. Right? Now H2 wants to respond you back. What would be the frame structure of the frame that is coming from H2 towards H1? Similarly, we have a payload, right? Here your source IP, destination IP, okay, and your blue one, if we assume that this is our layer 2 header, this will be my source MAC and destination MAC. Okay, can anyone tell me what shall I populate over here as source MAC when the frame is coming in the reverse direction from H2 towards H1? Source MAC will be
BBB.
BBB. Destination MAC,
A
source IP
1.2.
1.1.2. Similarly, 10.1.1.1. Correct? That's how our end-to-end communication happening when these both are in same VLAN. Okay.
Gaurav, I have a question. Hello.
Yes, please.
Gaurav, these the frames that you mentioned, is that the frames when the packets when the frames sending from the host or the switch the frame? How
Okay.
do my question is
I mean,
how
at
my
what point? You mean at what point this frame?
yeah, at what point? At what point?
At what
That's
point?
what
So,
yes.
okay. Okay, very good question. From H1 towards switch 1, what kind of link this is? Ethernet?
Correct.
So at Ethernet, we talk about frames.
Correct.
It should have Ethernet header. So this is the frame that is leaving from H1 towards H2, towards a switch. At this wire, this is the structure of this frame.
Yeah, but at that point, how do that frame have the destination MAC address?
Okay, that's what I said. That let us assume that H1 already knows the destination MAC address.
I see. Okay.
Okay, it already have. I mean that ARP response and ARP broadcast that has already happened. H1 already knows that in its ARP table what is the MAC address against this IP address.
Okay.
Okay, so when your frame leaves from this particular port on this Ethernet encapsulation, it has to do with the Ethernet encapsulation. Then this is the structure of that particular frame, and it remains same till our destination because this is the single. They both belongs to same VLAN. Okay, both belongs to same VLAN, or in other words, we can also say that this is in a single broadcast domain. Yes or no? I hope you guys are aware about what is a broadcast domain. And there is another one, collision domain. Anybody who is not aware about?
It would be good if you explained it.
Okay, all right. So when we talk about a broadcast domain, domain means an area, correct? So an area, and it's a collection of devices who can receive a broadcast message. So for example, H1 is sending a broadcast message, which all devices can receive that message. They all will be part of one broadcast domain. If let us assume that there are two more devices, H3 and H4, they were also part of same VLAN. Okay, they also belongs to VLAN 1, VLAN 1. But there was another device, H5, which was part of VLAN 3. Okay, so a broadcast sent by H1 will be received by H2, H3, and H4, but not by H5. Why is it so? First of all, do you guys agree that it will not, a broadcast sent from H1 will not be received by H5? Do you guys agree?
Agree. Yeah.
Agree. Okay. So because that is a different broadcast domain, that is not part of my broadcast domain. So when we are saying that this a frame is coming from, or that our packet was coming from H1, okay, that what is the MAC address against this IP address? That is coming as a broadcast packet.
Yes.
Right? To whom this broadcast will be sent or will be shared?
To everyone.
How switch is
Yeah.
deciding that which all ports should get that broadcast message? How this switch is deciding?
If there is no table, then it will broadcast to all VLAN 1 host.
Okay, so that means it is being decided based upon the source port on which that packet or that frame is being received. Okay, this R broadcast packet or R message has been received on port 1, which belongs to VLAN 1. So that means this broadcast can be sent to all the ports which are part of VLAN 1 only. I will not be sending that ARP request towards H5 because that is not part of VLAN 1.
Right.
Correct? Right. So that is being decided by this switch based upon source port. That is why in its MAC table or CAM table, it is maintaining this column also, VLAN. Which port is in which VLAN. Okay. Sorry. So that is the reason.
Okay.
All right. So I hope this is clear to everyone.
Yeah. And I have one more question, but I can ask later about the payload.
Yeah, payload. Yeah. What is the question?
What exactly? Is it the data?
It's a data. I mean, for example, you are sending an ICMP ping packet.
Okay.
Okay. So we are considering that this payload will be having this information about what is that packet, what is the protocol, or what is the actual data within that packet. So we are considering that as a payload.
Good.
Okay. So let's move ahead one step and think that this is a switch. Now, instead of this switch being only a layer 2 switch, it is also acting as a layer 2 or layer 3 boundary. There are some chat message. I'm not able to hear anything.
Yeah, that was me earlier.
Okay, you earlier. Okay. No, that's fine. Okay, all right.
But someone else, Ahmad was complaining that he is not able to.
Okay, Ahmad, are you still with us? I mean, are you able to hear me? No response.
Yeah, he replied that.
Oh, he replied, sir, issue resolved. Yes, sir. Okay, thank you. Thank you. All right. So let's move ahead and now assume that the switch is also acting your layer 3 boundary. So what do we mean by that? And I assume that this is my host A. Okay. And same way, this is the MAC address of host A. And the IP is 10.1.1. Assume 10/24. Right. Same way, on the right hand side of your switch, you have another host, that is host B, MAC address triple B, but the IP is, let's assume, 11.1.1.10. All right. So in order to communicate between host A and host B, what do we need? Guys, it's a question to all of you. In order to communicate between host A and host B, what is required?
Just source MAC, destination MAC, source IP and destination MAC.
Okay.
And
So that him you told about the requirements to create a frame.
yes,
Okay. I mean, we all agree that we require, in order to create a frame, we require all these fields.
source pointers.
Of course, IP and destination IP. Okay. Apart from this, can you see any other thing that is required?
VLAN. Port number.
Port number, which port number?
The device.
Who wants to know that port number? Let's say you are sitting at this machine. Let's say, okay, Ahmed, let's say you are sitting over here.
Yes.
Okay, and him, you are sitting at this point. Ahmed wants to communicate with him. Ahmed needs to know the IP address of him. Okay, I have this IP address. Source IP, I know my source IP. Source MAC, I know my source MAC. Correct? Destination MAC, I need to know. Yes or no?
Yes.
But there is a catch over here. What is that catch? Can you see Ahmed is sitting in a different subnet and him is sitting in a different subnet.
Yes.
They are no longer part of same subnet. How do you come to know? I mean, Ahmed himself knows that thing because Ahmed in its host machine, he has configured this IP address with a subnet mask of 0. Correct? And my destination IP is this one. So Ahmed automatically knows that the destination IP does not lie within my broadcast domain, within my subnet.
Yes.
It is not part of my subnet. So I need a device which can route my packets to a different subnet. Okay. So at least you need some device who can route your packets. Route means you need a router, or in other words, you need a layer 3 device. Correct? We can call it a router, we can call it a layer 3 switch, but in order to communicate between two subnets, guys, please note down these words. In order to communicate between two different subnets, you need a layer 3 device. In our previous example, we were discussing when both the hosts were part of same VLAN, same subnet, same broadcast domain. So when we call VLAN or when we call broadcast domain, okay, or subnet, same VLAN means same broadcast domain, means same subnet. Okay, so these all three terms, they are interchangeable. I mean, they all belongs to each other, same thing. But here, your purpose is to communicate between two different subnets. So you need a layer 3 device.
Yes.
Okay, or you need a gateway, right? So in your laptop, in your machine, you will also configure a gateway IP.
Yes.
And this gateway IP will exist on this particular switch. It can be configured on this particular port, or it may also happen that you configure, let's say this was part of VLAN 10 and this was part of VLAN 20. Correct? It may happen that you configure an SVI 10, which is having IP address 10.1.1.1/24. Similarly, the switch may also have another SVI. SVI is nothing but a layer 3 VLAN interface. This is a logical interface. Okay, which is used to route your packets. between two networks. So this SVI IP will be acting as your gateway for this particular host. So here also you will specify this as a gateway. Any questions till now before moving further? No? Okay.
No, sir. No.
Now think that from this host A, you want to communicate with host B, correct? Let's come to this frame again. I need a destination MAC.
Yes, sir.
So destination MAC cannot be of a different subnet. Please
Yes.
remember this destination MAC within my Ethernet frame. This is always from my same subnet or same broadcast domain. Okay. So when you
Yes.
send an ARP request from here, that where does this IP lies? 11.11.11.1.1.10. So this switch SVI interface will send you back with a proxy ARP. Okay,
Yes.
either it will send with a proxy ARP, or if you have already configured this as a gateway, so you automatically knows. So these are two different use cases. If you have not configured gateway IP, then this proxy ARP will come into picture. If you have already configured gateway, then you, as at your host machine, you already knows that for anything which is beyond my subnet, I need to send that towards this gateway only. That is the purpose of this gateway IP, that anything with which is not belonging to my subnet, I will send this towards my gateway IP. Correct? So you need
Yes.
this MAC address. Here the destination MAC address will be the MAC address of this gateway IP. This SVI 10 will have a MAC address. Okay, let us assume this was XXX. So in this frame, you will populate this XXX. And that's how your frame will be sent and received at this particular switch. Any questions so far?
So suppose we have not configured the gateway, how the proxy ARP work in that case?
Okay, good question, Him. So let us assume that this gateway IP you didn't configure over here. Correct? In your PC or your laptop, you have not configured this gateway IP. Then what will happen is it will send an ARP request over here. Okay, and if proxy ARP is enabled at this interface, by default it is enabled, it will say that I can act as a proxy for you. It will share its MAC address towards you. Proxy ARP means that thing only.
Proxy ARP has own MAC address.
No, proxy ARP does not have its MAC address. SVI 10 does have its MAC address, correct?
SVI 10, yes.
Okay, it is falsely saying that I can act as a proxy for any IP which does not belong to this subnet. I can act as a proxy for you.
Got it. When they reply back to the host A, what MAC address will send proxy ARP?
Sorry, say again.
So when the host A get reply from the so what MAC address will be back to host A?
This one.
XXX.
That I can act as a proxy for any other subnet.
Okay.
Send it towards me.
Got it.
Okay. So once this complete frame, it reaches to your switch, what will happen? Guys, please participate.
Check.
What will happen
next? We'll check the next source and next source destination.
Sorry, say again.
Check the next source IP and next destination IP when that will first request going to gateway.
So what will happen is this destination MAC. This is my own MAC. So it will see that this is a MAC address which is configured on myself. This is my local MAC. Correct? It will remove this header. Ethernet header will be removed. Correct? It will strip off this Ethernet header. Now it will check the IP packet. Now it will check the IP packet, that what I need to do with this packet actually. Right? You have configured two IPs over here as a gateway. You must have IP routing command so that it can route between two different subnets. By default, this is enabled. So it will check the destination IP now. Where does this destination IP lies? Okay, it will come to know that this destination IP lies within VLAN 20, for which SVI is this one. Then it will create another frame. Okay, and it also knows that, I mean, let us assume that in the MAC table of this switch one. Okay, I'll let us create a MAC table also, and assume that this is your MAC, this is your port, and this is your VLAN. Okay, MAC address AAA. This was coming at port 1 in VLAN 10. Let us assume it does have this knowledge. Triple B is on port 2, but is in VLAN 20. Right? So when from switch towards host B, I want to send this as a frame. Okay, I will have source MAC. I have destination MAC. I have source IP. I have destination IP. Can anyone tell me what is the value of source IP and destination IP?
Source IP will be the SVI IP. SVI.
Okay. Anybody else? Anybody else? Guys, source IP and destination IP never changes.
Oh, okay.
End to end. I mean, from my source till my destination, your source IP and destination IP never changes. It will remain as it is. Because if it changes, then your reply, how will host B come to know that to whom shall I reply? There will be a problem. Just keep in your mind, your source IP and destination IP will never change. They will go intact as it is. Your IP header will never change actually. Okay. Only the TTL or certain QoS fields that may change, but your source IP and destination IP are never changed. Okay, now source MAC. What will be my source MAC? Source MAC now, it will be the MAC address of your VLAN 20 interface. Let us assume this was YYY. Okay, this becomes your triple Y. And destination MAC is BBB. And this frame will be sent towards your host B. Once it reaches host B, what it will see is, okay, this MAC is my local MAC. What shall I do now? I shall remove this header. And then we'll see this actual packet. Within that packet, okay, it will check this is my local IP. What shall I do? I can remove this IP header and process this payload. Any questions?
What is going to be the routing statement for from VLAN 10 to VLAN 20? That
okay. The routing statement means?
I mean, there should be a IP routing command, right?
No. You need not to. You need not to, because on this switch itself, both the subnets are connected. You have this subnet and this subnet, both are connected at the same switch only. So if I check at my switch, I think you are talking about show IP route. What is the routing table? So in my routing table, I will see a connected route of 10.1.1.0. Yes or no?
Yes.
On let's say Ethernet 1. This is my Ethernet 1. And there will also be a connected route of 11.1.1.0 on Ethernet 2. Right? They both are connected locally. I need not to have any IP route statement because both are connected and both are part of my routing table.
Okay.
Okay. Few things you should remember: the source MAC, destination MAC, they remains significant within your broadcast domain. So between your host 1 and VLAN 10 interface, this was your one broadcast domain. Between VLAN 20 and host B, this was your another broadcast domain. So when we talk about Ethernet frame, my source MAC, destination MAC, they will be locally significant within your broadcast domain. As soon as you are leaving your broadcast domain, you are leaving your subnet, you are leaving your VLAN, your source MAC, destination MAC, they will be changed. But your IP, source IP, destination IP, they are never changed. They remain as it is, end to end. From your source machine till your destination machine, they are not going to be changed in your IP header.
Okay, understand.
Gaurav, is there any
Yes.
VLAN function or when we communicate VLAN 10 to VLAN 20 between when packets on the IP packets, that's source and destination 10.1.10,
Do you need
1.12?
do you need that information within your packet or within your frame?
Yes.
Why?
Yes.
Why I
How
need
we
that?
know how we know that we VLAN 10 we wish to communicate VLAN 20
No,
or the
no.
IP
See,
packets?
okay. See, from host to A, you are sending a packet, IP packet,
Mm.
right?
Source.
Source IP, destination IP. You're
Yes.
sending
Yes.
with some MAC address. Why do
Mm.
you need? Why do I need to say that I belong to VLAN 20? Do I need? So
So
that
how do
20 or
How
10, this was significant to maintain the switching table or to maintain the MAC table at switch only. Your host is not required to learn or to say that I belong to VLAN 10 and you belong to VLAN 20. This VLAN in tag or VLAN information, this is locally at your switch end to maintain or to divide your two broadcast domain.
okay,
That's it.
switch has already information 10 and 20.
Correct. Switch is maintaining that information in its MAC table.
Sure.
Nobody else need to know. There is no such requirement.
go to the IP packet header? It doesn't have the subnet information, right?
It does not have the subnet. Is it? No, it does not need to have subnet information. It only have source IP. It only have destination IP. I need not to have that subnet information because this is a unicast communication that is happening. In your broadcast also, if you are sending a broadcast packet, that also does not need to have your subnet mask.
Oh, Gaurav, when packet move from VLAN 10 to VLAN 20, in
Hmm.
that case, switch only check the MAC address table.
No. See.
No, no.
Uh,
Mm,
you are confusing two things. That's why I tried to explain it using this frame. See, this
mm,
frame reaches at VLAN 10 at this particular
mm,
switch. Now,
yes.
what it is going to do is it will check that this MAC address. This MAC
Mm,
address is my locally MAC address.
okay.
What I will do is I will remove this Ethernet header.
Mm,
Correct. Post that,
mm-hmm.
what remains is this
Source IP
IP header
destination. Mm,
plus payload. Correct.
okay.
Since I am acting as a layer 3 device, IP
Mm,
routing enabled. So
mm.
what I will check is I will check my routing table with respect to this destination IP.
Okay, I will check routes that they exist or not.
Yes, you are going to check your routing table that
Mm-hmm.
what should I do with this IP packet?
Mm,
So in order to identify the function or to identify the action for an IP packet, I will check my IP routing table. For a
mm-hmm.
Ethernet frame, I will check my MAC table.
Got
Right.
it.
So it's an IP packet. It will check that this needs to be routed towards VLAN 20,
Mm-hmm.
or don't think about VLAN 20. It has to be routed towards Ethernet 2 port. Correct. So to
That
send it
out.
towards, yeah, to send it towards Ethernet 2, I need to create a frame. To create that frame, again, I need a source MAC and destination MAC that you already know.
Yes, yes. Got it.
Okay, that's how you are
I'll check.
populating. Yeah.
That tells
Don't think about VLAN 10 inter working with VLAN 20 or how they are routing with each other.
No, that's
Think
work on IP. Got it. Now got
correct. Correct.
it. Yes, got it. Thank
Any
you.
other questions? This is important, guys. I mean, this is very basic, but everybody should understand this, how actually it is happening. We know that, okay, I'll be able to ping, this is the gateway if I configure, and host A will be able to ping with host B. But how at the underlay, how my packet or how my frame, what is changing? Your MACs are changing. Your IPs are never changing in your actual Wireshark packets.
One more thing that Gaurav, the payload have information. What type of information? The ICMP and like other
Yeah, payload
information?
have all that information.
Okay, whatever.
Payload have all that information.
Can I ask you one more question?
Yeah, please.
Okay, you said after the frame reach switch, then it check the IP routing table, then it remove the source MAC and the destination MAC, right?
Yeah, it will see that this destination MAC is local to me.
Okay.
It has reached its destination.
Okay.
With respect to Ethernet. So I'll remove that destination, or I will remove that Ethernet header.
Okay.
And then I will peel off this header and I'll check what is inside this frame. Then I'll find, okay, this is an IP packet. This is having an IP header.
Okay.
Then I need to check what is the destination IP. What should I do with this? I will check within my routing table. Okay. In my routing table, I can see that this destination IP, it is reachable via Ethernet 2 interface. This one.
And it too has that MAC address of this defined destination.
It does have this MAC address. This Ethernet 2, it belongs to VLAN 20. So within my VLAN 20, do I have a MAC address for this destination IP? Yes, I have. Okay. Along with the MAC address, I will also have an ARP entry actually. So ARP entry will say this destination IP 10.1.1.10 does have a MAC address of this one. So from this ARP table, it will come to know that this IP does have this MAC address. Now it will check in its MAC table from where I can reach this MAC address. This MAC address is reachable via this port and in this VLAN 20. So it will create this frame and send it out of this Ethernet 2.
Okay.
Okay.
Yeah. Good.
All right.
Gaurav, I joined the class 30 minutes later. Can you just tell me what exactly the broadcast domain in words so that I can?
Okay. Yeah, broadcast domain in words, I would say that if I send a broadcast message,
okay,
which all devices can receive that broadcast message, they will be part of my broadcast domain. That is the area, or that is how I will confine my domain. Who can receive that broadcast message?
Okay.
That or in other words, one VLAN, we can say that this is one broadcast domain. If any host within VLAN 10, if it is sending a broadcast message, all the devices who belongs to VLAN 10, they will receive that message. No other device will be able to receive that message. That's why we say that one VLAN is equal to one broadcast domain. And in IP or in layer 3 terminology, one subnet is one broadcast domain.
Okay, thanks.
Right. All right. Okay, so this we have learned. I'll clear this thing. So we talked about this MAC table. Okay, it is also known as CAM table. This is one and the same thing. The full form of this CAM is content addressable memory. Okay, this is also known as your content addressable memory. So what it is doing is it is storing your layer 2 information or MAC addresses along with the port number and the VLAN number. That's how we are storing. Correct. There is another term that is known as TCAM. This is known as ternary CAM. ternary content addressable memory. Okay, so this this ternary content addressable memory, it does stores your, it is used to store your access lists. Okay, or I mean some upper layer things like quality of service. This is also being stored in your TCAMs. This is a separate memory than your CAM. That's how we have within our switch. So what is the purpose of CAM table or your MAC table? If your switch receives a frame, the purpose is, where should I forward that frame? So if your switch is asking this question, how he is able to solve this question? Using what? Using MAC table or CAM table. Where should I forward that frame? But if I have a question, should I forward that frame? Is there any access list who is asking me to drop that packet? Is there any quality of service who is telling me that shall I pass that frame or shall I drop that frame? That is being answered by your TCAM. So when you configure, or when your switch is populating its MAC table dynamically, or it can also be configured statically, that information is being stored in your CAM table. But if you are applying or configuring any access list or quality of service configuration, that is being stored in your TCAM, that is ternary CAM.
Or TCAM store in L2 device or L3 device?
TCAM is there in your L2 as well as L3.
When we create an access list, they will store.
Correct. I mean, access list is just an example that gets stored within your TCAM. It also stores your quality of service things. Why? I mean, if you, just to make you remember, ternary means, I mean, in English, or I don't know if it's an Italian word or some other word. Ternary means three values. Okay. I mean, in binary we have 0, 1, or we can call 0 or 1. Anything is acceptable. So these are the three possible values. If you remember in our ACL also, how we configure our ACL, we try to match, let's say, access list 10 permit 192.168.0.0, and then we give our wildcard mask 0.0.255.255. Correct? That's how we give. Okay. So what does that mean? So there will be something which we are masking. Masking means this is your wildcard mask. So in this ACL, are you aware about access list? I mean, have you gone through it in your CCNA or in NRC classes?
Access control.
Yes,
Access control list. Anybody who is not aware about this thing?
Particular traffic and all of it. Yes.
Yeah, filtering or identifying your traffic. That's the purpose. Anybody who is not at all aware about this thing? We are not going too deep. I'm just trying to tell you why ternary, why ACL is coming over here.
Yes, please.
From my side.
Sorry?
So I'm unaware, sir.
Okay. So what we want to do in access list is we want to identify some IPs or some host using access list. That is the purpose. Okay. Then we apply that to stop any traffic or to filter any traffic, maybe by permit or deny statement. That's how we can filter. Okay. So here we are specifying this thing. What actually it means is, this means your first two subnets must match. Okay, this 0, actually it is a wildcard mask. So it's an opposite of your subnet mask. So it means this is something which must match in order to be identified using this access list. If I check with this particular IP 192.168, let's say 10.1. Is it matching with this one? Yes, it is matching because
Yeah.
I'm matching this first two subnet. For rest of the two things, I'm saying they
Yeah.
can be anything. They can be
Anything.
0 or 1. I mean, 0 or 1, this is, I'm talking about in terms of binary values. Okay, this is
Okay.
a decimal number, but if we convert this into binary, this becomes 0, 0, 0, 8 bits. Correct?
Yes.
So we want to say that using this wildcard mask of 255, that this can be anything. It can be 0 or it can be 1. But here we want to say that it must be as it is. This must match. So if it is a 0, let's say this value, hypothetically, if I assume that this is this one, okay, 4 and this one. So at first place, it must be 1. At third place, it must be 0. That's what we are saying. Correct?
Yeah.
So these are the
Yes.
three possibilities that we want to store within our TCAM using this ACL. That this
Yes.
value must be 0 or this must be 1 or this value can be anything. These are the three possible things that we store within our ternary CAM. Three values that we store. Okay, that's how you can remember that what is the difference between CAM and your TCAM.
Yes.
In CAM, we are storing our MAC table. MAC table, you already know your MAC address, your port number, your VLAN information. In your ternary CAM, you may have three possible values that are coming with your access list or your QoS ACLs. In your quality of service also, we configure ACL to identify our traffic. So that's being stored over here.
Thank you, sir.
Okay. So I okay, let's do one thing. Okay. So in this topology, I have connected this R6 and R5 over here, and I'll just power on this 4 devices. So this AG1 and AG2, they are acting as switch, and this R5 and R6 will assume that they are working as a host. Wall nodes. Let's say I make this as AG1, and this one 5 net AG. All right. At R5, AG1. If you check show interface status, all these ports are part of VLAN 1 as of now, right? How can you check your CAM table? Show MAC address table. That's how you can see. Okay, and it is being shown for particular all the VLANs. VLAN MAC address, how it has been learned statically or dynamically, and this the port number. You can also filter it for a particular VLAN, or you can also filter for only list the dynamic MAC address. Let's say you select for VLAN 1, so then only VLAN 1 MAC addresses will be shown to you. That's how you check your MAC table, right? So at R5, if I configure host name R5, interface E0 by 0, right? At AG1, I have a MAC address from E0 by 2. This is E0 by 2. They are learning each other. At E0 by 3, I do not have. If I check the status of show interface E0 by 3, which is going towards your host R6, this is up state. But so far we are not learning anything. Why we are not learning? At R6 end, if we go ahead and check, do show IP interface brief, these all are admin down. That's why so far you have not learned anything. Okay, let's do one thing. Let's try to capture this E0 by 3. Okay, and on R6, if I just power up this interface, no shut, and see what will happen over here. Can you see this CDP messages you are learning at E0 by 3 now? Cisco Discovery Protocol. Okay, so within this Cisco Discovery Protocol, I'm learning this. I should get a MAC address also somewhere. Capabilities, port ID, okay, 0 by 3, native VLAN, that's nothing, flex. If we go back and check on AG1, see, at E0 by 3, you started learning this MAC address. And how you are learning this is via the CDP or VTP messages that are being exchanged automatically over here. Okay. Or there is another way also at R6, and if you just put an IP address over here, if I just put an IP address 10.1.1.10, what will happen? If you configure it, it sends a GRP message. Can you see this one? Gracious ARP. What is the purpose of using this gratuitous ARP is to check the duplicacy. Okay, so that anybody else does not have this IP. How it is checking that duplicacy is? Can you see the sender IP and the target IP both are same? This is my IP address at R6 that I have put. I'm sending a IP packet or GR message packet with the target IP also same. If there would have been any other host that is having same IP, he would have replied me back. That's where you get that duplicate IP address configured messages using this GRP message. That's the purpose. Okay, and this GRP is also sending you the sender MAC address. It is being broadcasted, all F. Okay, so via this source MAC also, your switch will populate its MAC table that on port E0 by 3, this is the MAC address that is lying. Okay, so that's how it is learning. Now, if I show you at AG1, VLAN 1, that's how we are learning. Show MAC address table. There is a command aging time. So this is the default aging time. As I told you, 5 minutes is the default, 300 seconds. This is the default one. You can change that also. Okay, the command will be MAC address table aging time. You can change that time also. Okay. Another thing. Yes.
Gaurav, what's the purpose to change the time, agent timing?
It may happen that your some of the servers that you already know. Okay, I know that on this particular port, there is a server which is connected and there is no keep alive mechanism being sent over here. Okay, and you do not want and there is something that it cannot respond you back to your ARP messages also. Okay, and you do not want that this MAC gets flushed from here for a longer duration.
In that case, we can put the static MAC address.
You can put static also, but you do not want to put it statically. I mean, there could be a use case when this server is a virtual machine, or you for example, this server is in a different administrative domain. There are different server admin is different, and the network admin is different. They both are different people. Okay, your server guy says that I can change this server anytime, but I need not to call you to every time to make the changes, corresponding changes at your network end. So statically will create a problem that every time if he is changing that server, he'll need to call that network guy to change that, to update that MAC address.
MAC address, yes.
Okay. So that could be, I mean, that these are the use cases that you may see in your production environment, but everything has its own purpose. These are the utilities that are being provided. Okay. I'll clear this one. So you can increase the aging timeout. Apart from this, at your port level, or I would say MAC address table, statically also you can define. For example, if you say that do show MAC address table, this is you are dynamically learning on E0/3, correct? Okay. And if you want to define this statically, MAC address table static, and let me define this static address, and you want to put that in VLAN, let's say 1 on interface E0/3. So this is being stored in your running configuration. Okay.
That is also the port security. Gaurav. Nobody even connect only this MAC
Yeah, we
address.
have. That works dynamically. Okay. Port security that will come in our course, but that runs dynamically. Here we are statically defining this one. Okay. And if you check your MAC table now, show MAC address table VLAN 1, you can see that this is statically defined. Okay, this is statically defined. It may happen.
No one connect in those particular. Okay, the port is against this MAC. Got now. Thank you.
Sorry.
Got it. I understand. Thank you.
Okay. So this is statically there. So I mean that's how you can check in your MAC table also which all are static and which all are dynamic. That's how you can check. Okay. So what else shall we cover today? Actually, our today's class will be there. I mean, will be short. Will not take it till 12 or 12:30. So that's what we have covered so far. In our next class, yes, we'll be taking it further. Okay.
So
next
sorry
class.
to,
Yes, please.
Gaurav, sir, sorry to interrupt you in between. Sir, actually, I want to know means would I get a live recording for this session?
Correct. You will get the recordings.
It would be by today, or means how it would be?
As per my past experience, this get uploaded in a day or so. I mean, maybe by Monday you will be getting that.
Okay, no issue. Yeah, thank you, sir.
Okay. Yeah. So next week, because we have festival also, you will get a prior information when we are going to schedule our class. It may happen for 1 or 2 weekends. We'll have to take our classes during the weekdays, but we'll be doing after office hours, maybe in the evening time, 8 to 10 or so. Okay, but you'll get the information via email.
Yeah, sure.
Right. Thank you so much, guys. Thank you.
Just last question.
Yes, please.
You just put a static IP on that Ethernet, like 0/3. Whenever suppose when other one is connect on this particular MAC, we have to remove that MAC address statically. Suppose that what is the MAC address that is used? The AABB. What is the MAC address? That port MAC address. That's a device MAC address.
This is the MAC address of the port of R6 E0/0.
Yes.
If
Sir,
you
it is
if you check on R6 interface E0 by 0 include via, this is the MAC address.
Port. If
Port.
you want to connect, if you connect on second one port on the same port in device, we used to connect on second device on same port. Remove this device and connect the second one. They will able to connect on that port or not?
not port.
Because you put the static IP. Suppose I remove R6 on that host on that particular port.
Okay. So I
connect
think
on-
you are saying that
Hmm.
you at this port, if you connect any other device,
Yes, yes.
will it work or not?
Yeah, yes, yes. You
Right.
because you put a
Okay,
static.
well, yeah, we can check that easily. Add this. Okay, if I remove this one,
Hmm.
okay, instead of this one, I put a different MAC. Will that be same scenario, right?
Yes, yes.
Right.
Mhm.
Show MAC address table. It will be connected. At one port, you can receive multiple MAC addresses. Static is there, but you are dynamically also learning at the same port.
We will connect on one device and one port. No? Always taken two. The one is static, one is dynamic.
We can receive multiple MACs also, na?
Okay, same port we can multiple MACs.
Correct. You can have, let's say, you don't know, you have connected a hub over here, and here you have multiple hosts.
Yes.
Okay, similar scenario. I mean, at a single port, you can receive multiple MAC also.
So one query, sir.
Yes, please.
Yeah, so why means why you have configured MAC address as static? It is for port security you have configured.
No, it may be a requirement. It may be a requirement that you do not want to learn this MAC address dynamically. You want to configure that statically. For example,
but it would be act as a port security as well.
Port security is a different concept, but yeah, this could be considered as a security method. Yes.
For the device security, that will be key.
Yeah. Okay.
Yes.
For example, on your switch, you do not want to learn anything dynamically. On this particular port, you are sure that there is a firewall which is connected.
But Gaurav, in the real environment, VLAN never check in a static IP, static MAC address.
Rarely, yeah, that's what I'm saying. It is rarely configured. It is rarely configured, but there can be several use cases wherein your server or your end device, it is not sending you its MAC address.
Yes.
Okay, but you still want to be in your that MAC in your MAC table. That's how you can statically also define.
Okay, understood. Thank you.
Okay.
Gaurav, this is the first day I joined for this. Is this the first, or there was any previous session?
No, this is the first class for ENCOR.
I see.
This is the first class.
And I think I missed the first 15 minutes because of my audio issues. And
no problem. You'll be getting the recordings, and I don't think that was much that you have missed. You'll get the recording. Watch you go through the recording. If you still have any questions, we can discuss in our next class.
Okay.
You will continue, Gaurav, with us for ENCOR course, no?
Correct.
No,
sorry.
The structure will not change. You will continue with us, no?
Yes, I'll be continuing.
Because you will take an NRC with you, no? So that is good.
Yeah, I remember.
Thank you.
For the next session, how do I get this? Do I need to go to the portal or I get email for the link?
I mean, since this is just a beginning, you will be getting communication maybe via WhatsApp or the email, whatever communication message method will be there. You'll get the intimation. But for our regular classes, you will be. I think you must be having that app. Within that app, you will get the notification.
Or Gaurav, lab also available for this NRC ENCOR, no?
Yeah, same way as like we had in our NRC. Here also we will have.
Okay, thank you.
All right.
Yes.
Thank you so much, everyone.
Thank you.
We'll connect next. Thank you. Bye-bye. Bye.